Say that we have been asked to find the value of this given expression sine 25 times cosine of 65 plus cosine of 25 degrees times sine of 65 degrees. So just looking at the problem, I see that 65 degrees and 25 degrees aren't just general angles. They are very special. In fact, they are special related to each other. So we have already discussed in the channel that the sine of some angle theta and the cosine of that complementary angle 90 minus theta are the same. We have seen this result in the channel. I'll provide the links in the description, but even if you haven't, this happens because the sine of theta is opposite by hypotenuse for some opposite and hypotenuse in a triangle, and the cosine of 90 minus theta, which is precisely this angle, is adjacent by hypotenuse, and it turns out that it's the same ratio. And this was the reason why you can also think of their names as sine and the complement of sine. The co stands for complement of sine, and it's not the complement where each other they call each other beautiful. It's a complement with an e. So the theta and 90 minus theta are complementary angles, and the sine of theta and cosine of theta are the same. Well, I think somehow we'll have to use that result in this expression, because 25 and 65, if you add and look at them, so 25 plus 65 is 90 degrees. So these two angles are complements of each other. Well, if they are complements of each other, then I know that sine of 25 degrees and the cosine of 90 minus 25 degrees would be the same. So I'll write it as cosine of 90 minus 25. Let me use the same color. Cosine of 90 minus 25. So I haven't changed the expression yet, because I have just written 65 degrees as 90 minus 25 degrees. So I haven't changed, altered the expression. Let me put a degree symbol up here, and this has to be added to, let me erase this off, because I think now we have an intuition for it, we'll remember it. I'll add it to the cosine of 25 degrees, and the sine of 65 degrees can be written as the sine of 90 minus 25 degrees, right? And maybe we can proceed from here. So what happens is these both are equal, and what happens is the sine of 25 degrees will keep it as such, because it turns out that this can be written in terms of sine, because they are complementary angles, cosine and sine. They are complementary ratios, and these are complementary angles. So I could write this as sine of 25 degrees. And now we have two sines, so maybe we can do something with that. And if we have two cosines here, then we might be lucky, because we know one other identity with sines and cosines. So the sine of 90 minus 25 degrees can be written as the cosine of 25 degrees. With the same logic, it turns out that both the ratios are the same. If you are very confused about the proof, you can go back and watch it anytime you want. So this turns out that it is equal to the sine of 25 degrees whole squared, because there are two sines multiplied together, and plus there will be a cosine of 25 degrees squared. Now this another way of writing this same expression would be sine squared 25 plus cos squared 25. Both mean the same, and we know that this is the Pythagorean identity. So the sine of some angle, sine squared some angle, let me write down the identity before using it. Sine squared theta plus cos squared theta for any theta between 0 and 90, because that's what we have studied. We have only looked at sines and cosines for acute angles. So sine squared theta plus cos squared theta for any theta will be equal to 1. So this whole thing turns out that it is equal to 1. So what was equal to 1? Let me just copy down the problem because I want to discuss about this further. This is some interesting insight for you guys. So if I bring this down, so it turns out that this whole expression was equal to 1. And now I am going to go out on a limb and say that this happens, all of this business turns out that it is equal to 1 happens fundamentally because at the root cause it is because sine of 90 degrees is equal to 1. Why am I saying this? I am implying that sine of 65 degrees plus 25 degrees is equal to, we know that this is equal to sine of 90 degrees, but I am saying that this is equal to this business right here, so this LHS. So let me bring this down, and if this is confusing to you, then very good, because it should be. You haven't studied this, we haven't proved this, but this might be just an insight for you for upcoming trigonometric ratio classes you might have in your further grades. So I am saying that if sine of some angle plus some other angle is given, you couldn't just write this as sine of 65 degrees plus sine of 25 degrees, right? This is not how it works. It is not like saying 2 times a plus b is 2a plus 2b. This can be done, whereas this cannot be done, and I am implying that this happens because all of this were equal to 1, because ultimately sine of 90 degrees was equal to 1. We know this by our calculations, and this sine of two angles added will be equal to the sine of one angle times the cosine of other angle plus the cosine of the first angle times the sine of other angle. So I hope this was a good trailer for you to what's upcoming in your next grades, but for now we'll just stop with this part. For now, if you understand this much, it's more than enough. Thank you.